So last time, if phi of z has complex roots, we ended up getting this, but seems like there is I in psi j, but we want the psi weights to be real, right? We don't want complex roots. But if we go back and look at how C1 and C2 are defined, for an AR2 case, how do we define C1 and C2? Done it before. Yes?
But wouldn't that not work if the lambdas were repeating? Or is this not that case?
No, it's not that case. C1 and C2 will still be the same. So lambda 1 over lambda 1 minus lambda 2, lambda 2 over lambda 2 minus lambda 1. So if the roots z1 are imaginary, 1 over lambda 1 will also be imaginary. Do we agree? Excuse me, 1 over z1. So if the roots of the characteristic polynomial are imaginary, lambda 1 is imaginary. If lambda 1 is imaginary, lambda 2 is imaginary, the ratio of those two will be imaginary. Correct? So I could simply write C1 and C2 to be some random imaginary number. We have to solve for it depending on the problem. So in this case, it's alpha plus I beta and alpha minus I beta. They have to be conjugates also, right? So for some alpha and beta. So all I'm trying to say is if the roots are complex, the lambdas will be complex. If the lambdas are complex, the lambda over lambda 1 minus lambda 2 will be complex, and so forth. So if that is the case, I can go back to psi j. If I plug in alpha plus I beta and alpha minus I beta, we'll have cosine theta j plus I alpha plus I beta minus alpha plus I beta sine theta j. Correct.
Should that be the conjugate?
Yeah, but I'm distributing the negative, right? So in the first term, the I betas will get cancelled. So we will have 2 alpha cosine theta j. In the second term, alphas will get cancelled. I will have I times I beta sine theta j.
Wait, what did you say you were? Like, why is it not the conjugate again?
I'm distributing the negative in here.
Oh, what did that minus be 0?
So if I distribute the negative, right, I'll get negative alpha plus I beta. The first term is just C1. It's alpha plus I beta. So alpha plus I beta is right here. After distributing the negative, I get negative alpha plus I beta.
Wait, so that wouldn't be zero? Honestly, it looks like it should be zero there.
It's not zero.
Plus I beta minus a plus I.
Look, alpha plus I beta is C1
Yes.
minus alpha minus I beta, C2. Distribute.
Oh, no, I see what you're saying, it's just the way it looks, okay.
Yeah, I was having trouble not seeing the whole thing as one term.
Yeah, I skipped a step, my bad. So all I did is C1 minus C2, distributed the negative. I skipped that step and went directly to that. So I can see why you guys got confused. So I squared would be -1. So -1 times beta sine theta j. Good. Now, is that a real term? Or in other words, would that give me real numbers?
Yeah.
Absolutely, because I don't see any I here. So eventually psi j became just real number values. So a term of importance is theta j. Specifically, theta j simply plays a role with psi j. But what is theta? Theta, remember the formula that we had for theta is tangent inverse of b over a. From the roots. You can use cosine, you could use the sine, but I like using the tangent part.
And you said the J was just. Sorry, I was ready when you were talking about the J. What did you say the J was? It was just.
J just belongs to the J here.
Okay.
So we could write theta as 2 pi f, where f is what we call the system frequency. So
Is that a theta right there?
Yeah.
Okay.
is that a 0 or a
Theta.
It's like a claw.
It's a theta, right?
yeah. So 2 pi f is equal to theta, so f would be theta over 2 pi. So, right, so we started with side A. This is from last time. Then I mentioned, even though we have a complex number here, we can get rid of it because C1, C2, they are complex themselves. Plug it all in side A and simplify, we end up getting this term, which is real. And we know theta, how to get theta, tan inverse of b over a. And f is what we call the system frequency, theta over 2 pi. T is simply the time. Time is always the inverse of frequency. So 2 pi over theta, this is the period of the cycles that we would see. So what do I mean by that? Typically, when we have complex roots, the correlation function would start having cycles. I think I showed this last time. So we want to know the period or at which things oscillate back and forth. And that period can be found using this formula 2 pi over theta.
What do you say? It fluctuates, like it's not, so it's positive and next person.
Right. With a period, it will repeat with a certain period, just like a sine wave, sine repeats with the period of 2 pi. But here, depending on the series, sine j would vary with the period 2 pi over theta. Whatever is called the system frequency. Good.
Yeah, so you use the theta that you find from there and plug it into that. That's
Yes.
what- Okay,